All right, in this video, we're going to continue working through our Chapter 5 review. We'll go through as many as I can before school starts. So next up is using the sum and difference rules. And so we should know what those are at this point. And so we know that we have, well, I guess before we get into the rules, let's figure out what we're going to do to create them. So 105 degrees, we've done this one before. That's going to be 60 plus 45. 195. Let's see. That looks like 180 plus 15, but we really don't know 15, so that's not very helpful. So let's back up to 150. There it is. 150 plus 45. So 150, that's 5 pi over 6. And then 255, let's see what we can do there. 255, again, let's see, we have 270 minus 15, but that's not going to work because, I don't know 15. So what are we going to do here? 270 minus 15, let's try an addition instead. So 210 plus 45, and 210 is 30 times 7, so this is 7 pi over 6. So yeah, we are good to go. We have our ways of getting to each number. And I don't know about you, but I do prefer radians at this point than degrees. So I'm going to say this is pi over 3 plus pi over 4. 150 is going to be 5 pi over 6, because it's 5 times 30 degrees plus pi over 4. And 255 is 210, which is 3 goes into 21 7 times, so it's 730s, so it's 7 pi over 6 plus pi over 4. All right, so now that I have that figured out, now I know I need, looks like the sum formulas for each of them. So part A, the sine of pi over 3 plus pi over 4 equals the sine of the first one and the cosine of the second one plus the sine of the second one and the cosine of the first one. All right, so pi over 3 sine is going to be root 3 over 2. Cosine is root 2 over 2 plus root 2 over 2. And the cosine of pi over 3 is a half. So I get root 6 over 4 plus root 2 over 4, root 6 plus root 2 over 4. Part B, the cosine of 195. So we're doing the cosine of 5 pi over 6 plus pi over 4. So this rule is cosine of the first one and cosine of the second one, and minus sine of 5 pi over 6 and sine of pi over 4. All right, so now we just need to figure those out. The cosine of 5 pi over 6 is going to be a negative number, and the cosine is going to be root 3 over 2, root 2 over 2. Sine of 5 pi over 6 is positive, and that's just going to be a half, and root 2 over 2. And so I get negative root 6 over 4 minus root 2 over 4, negative root 6 minus root 2 over 4. And then part C, Normally, I would just do like sine divided by cosine, but I have different values, so I have to know the tangent formula. So what do we have here? Tangent of 7 pi over 6 plus pi over 4. All right, so the tangent rule is tangent of each of them. So tangent of the first one plus tangent. Sorry, computer's locking up on me a little bit. Plus tangent of the second one over 1 minus tangent of each of them. All right. Well, I don't know my tangents from my unit circle as well, so I might resort to using a triangle to help me out here. So tangent of 7 pi over 6. Pi over 6 would be 1, 2 square root of 3. And so my tangent of that's going to be 1 over square root of 3. And tangent in quadrant 3 is positive. 7 pi over 6 in quadrant 3. Plus 1 over 1 minus tangent of 7 pi over 6 again. So that's 1 over root 3. And tangent of pi over 4 is 1. So I appear to have, I need a common denominator. So I'm going to multiply by root 3 over root 3. And so I get, it's getting kind of messy here, 1 plus root 3 over root 3 over root 3 minus 1 over root 3. Which we know the root 3's are going to cancel when I multiply by the reciprocal, leaving me with 1 plus root 3 over root 3 minus 1. I'm going to rationalize now. So I'm going to multiply by the conjugate. Which is going to give me root 3 and root 3 on the bottom gives me a 3. Everything in the middle is going to cancel out and a minus 1. And the numerator, I get a root 3 plus 1. Root 3 and root 3 make a 3 and another root 3. Just make sure that's correct. Something feels off about it for some reason. I'm just going to double check my math. Root 3 and a 1. Yep, looks good. So I get 4 plus 2 root 3 over 2. So the answer would be 2 plus root 3. Okay, there we go. All right, what else we got next? Find the exact value of cosine of 75 degrees. I'm going to skip that one. We just basically did one just like it, so I have faith you can do it. All right, number 18, looks like we have some double angle formulas. What are they telling me? That the angle in question, theta, is between pi over 2 and pi, so it's in quadrant 2. If the angle we're talking about is theta with a tangent of 12 and 5, and that would mean a little Pythagorean theorem action, I believe would make this 13. 144 plus 25 is 169, which is 13. Our tangent, so this is in quadrant 2, so I suppose I could have drawn it in quadrant 2, but the takeaway here is only the 5 is negative because the 12 would be positive. Okay, so now we just need to use our formulas. So part A, the sine of 2 theta is equal to 2 sine theta cosine theta. And so that's 2 times 12 thirteenths and negative 5 thirteenths. which gives us 169 on the bottom and 120 on top. The bottom is just 13 and 13, so there are no common factors. Oh, it's negative. And there you go. Part B, the cosine of 2 theta is cosine squared theta minus sine squared theta. And so the cosine of theta, once again, is going to be negative 5/13, and that's being squared, minus 12/13, and that's being squared. So I get 169ths minus 144 169ths. And so what do we got? 144 minus 25. Carry the 1. I get 9 and a 1 and a 1. 119. Looks right. So negative 119 over 169. And then part C, I'll do over here. The tangent of 2 theta. All right, this is the one I don't have memorized. I think I could be close if I tried, but I don't need it because I can do sine of 2 theta over the cosine of 2 theta. And so that brings me to negative 120 over 169 divided by negative 119 over 169, which, little magic here, gives me 120 over 119. Okay. Negatives cancel out. Looks good. All right, let's see what's left. All right, just another practice with this one. So I'm going to skip this one. I'm going to make note that we're in quadrant 3 this time. So when we make our triangle, both the x and the y will be negative. All right, so I'll let you do that. Number 20, we'll at least do a piece of this. The sine of u and the cosine of v. The mistake you might get confused here is you might think u and v maybe come from the same triangle or something, but that is nowhere stated in fact. And in fact, I think the math wouldn't even support that. So we're in quadrant 3. So on one hand, we've got our angle. We'll label it in the right quadrant. So let's call this will be our u. And so the sine is negative 1, and this is 3. So the Pythagorean theorem makes this the square root of 8, or 2 root 2, also negative. And then v is also ending in quadrant 3. And the cosine is negative 7 over 8. So that's going to be what? 64 minus 49, which is going to be what? Same as 65 minus 50. This is 15. And so the square root of 15 cannot be simplified. And we get the square root of 15, and it is a negative number. So now that I have all that figured out, then going through and doing these should be trivial. I'll do one of them. Let's do B. So the cosine of u plus v. Don't forget this is the one that has a negative inside of it. So cosine u cosine v minus sine u sine v. The cosine of u is negative 2 root 2 over 3, and the cosine of v is negative 7/8, minus the sine of u is negative 1/3, and the sine of v is negative root 15 over 8. So what does that leave us with? Positive, looks like 14 root 2 over 24, which can reduce, minus 2 negatives make a plus, so it stays minus root 15 over 24, which cannot reduce. So actually, it's a good thing I didn't reduce it yet, because if I want to combine them together, I would have 14 root 2 minus root 15 all over 24. All right. So I'll let you do A and C. And finally, the last one, just another verify question. So I think here we don't want to fall for the trick, right? We don't just square each piece because this is a binomial being squared. So we have to use either FOIL or a shortcut. So this becomes cosine squared x minus 2 sine x cosine x, and then plus sine squared x. All right, so this is what I'm trying to prove. All right, clearly my answer only has sine in it, so I'm thinking I'm going to need to do some sort of conversion here. Although I've got this one cosine sitting right there in the middle, that's going to be problematic. And so let's see if we can kind of game plan this in real time. I could do like a partial factoring, factor out a single cosine, but I don't see that's going to do any good. All right, I don't know. I might end up erasing this and trying something else, but I think I'll turn cosine squared x into 1 minus sine squared minus 2 sine x cosine x plus sine squared. Okay, that's nice. My sine squareds cancel out. And so I'm left with a 1 minus 2 sine x cosine x. And that's when I notice, oh, it's not sine of x that I'm trying to get, it's sine of 2x. And sine of 2x, we know, is 2 sine x cosine x. I have a 2 sine x cosine x, so I can put that back together as the sine of 2x, and I am done. All right, I did not see that coming, mainly because I did not notice the 2x in the question. Had I noticed that, it probably would have given me more confidence that I was doing it right from the beginning. All right, hope this has helped. Let me know if you have any questions.